An experiment was conducted to measure how quickly adults respond to the request, "Send me a text message." Let t equal the number of hours taken for an adult to respond and send a text message. It was found that the distribution of the population of response times for adults was given by the probability density function shown below, with mean mu equals 3 hours and standard deviation sigma equal to 2.4 hours. So what we know so far is that t is normally distributed with a mean of 3 and a standard deviation of 2.4. Random samples of size 64 are drawn repeatedly from the population of response times, and the sample mean response time, t bar, is determined for each sample. Calculate correct to 0.01001, the probability that sample mean response time will be between 150 minutes and 210. Well, first of all, we know that t bar is going to be normally distributed with a mean of 3 and a variance of 2.4 squared over 64. And that means, of course, that sigma for the sample is going to be 2.4 over 8, and we can calculate that, and that is 0.3. And then we're after the probability of t bar being between 150 minutes, which is 2.5 hours, and 210 minutes, which is 3.5 hours. So we can go interactive, continuous, normal CDF. The lower is 2.5, the upper is 3.5. Our sigma is 0.3 and the mu is 3, and that's 0.904 to the correct degree of accuracy. Sketch the likely distribution of the sample mean t bar for samples of size 64. Well, we know the mean is going to be at 3. I want to get some sort of accuracy into this, so what I'm going to do is go to normal PDF. That gives me the height of the curve at various points. So if I put in x is 3, this is 0.3, and the mean, of course, is 3. And that gives me 1.33. So if on this scale I say that this is 1, it doesn't quite work for me because the top will be 1.25, but it will be just above there. So if we say that that's 1, let's put 0.5 there. And then let's move across a little bit. So let's say we go to 2.5. That's going to be at 0.33. So 0.33 on this scale would be about here. And so we've got there as well, because of course it's symmetric. And if we go to 2, that's really small, 0.005. So it's going to be virtually on the axis here. And we know the shape of a normal, so it's going to have the familiar bell shape like that, and it's just going to basically go along the axis from there. So it's going to do this type of thing. Okay. Annika, a teacher at the Technocrat School, theorizes that as teenagers tend to check their text messages more frequently than adults, then the population mean response time for teenagers will be much lower than the population mean adult response time, mu equals 3. Annika is then presented with the sample mean response time for a sample gathered from an unknown source. Now that is of crucial importance. We do not know the source of the information she has. Calculations are performed and Annika concludes by stating this sample was clearly not taken from the population of adult response times. It is highly likely that this sample was taken from a sample of 100 teenagers. Form the necessary calculation and comment on Annika's claim. Well, we can certainly do a 99% confidence interval here. Now, there's 4 marks, so you might want to show at least some working. So I'm going to make use of the activities, and I'm going to go into my Z-score for CI, and I'm actually going to do this with a 99% confidence interval. And so I am going to say Z95 is 2.5758. Then I'm going to work out my confidence interval. And I'm just going to use my e-activity for this. So confidence interval for mean. So the first thing I need to put in here is the mean. And the mean here is 2.1. The next thing is the standard deviation, which is 2.7. There were 100 people in this sample, and we're doing 0.99. And that gives me 1.405 up to 2.7951. Now remember, if you don't use the e-activity, then the calculation would be 2.1 take away the z-score of 2.5758 multiplied by 2.7 divided by 10, which is the square root of 100. And that gives us the 1.405 that we had just here, and with a plus just in there, we would get the top end. Now, simple fact is that the adult mean of 3 is not even close to being inside this 99% confidence interval. Now, that would certainly suggest that the sample here is not drawn from that adult population. However, we can't go along with Annika's claim because of what we highlighted up here. It's an unknown source. So while we might be able to say that it wasn't drawn from this adult population, we can't say who actually was involved in this sample, what population was involved in this sample. So when she says it is highly likely that this sample was taken from a sample of 100 teenagers, that's the part that we can't really go along with, and you need to comment on that.